Welcome Internet. In this video I want to talk about primitive data types inside of Unreal. First things first, I want to talk about Boolean. For everybody who does not know what a Boolean is just a representation of true and false values, where true is 1 and false is 0. So where do you need it? You need it for each logical aspect inside your game. For instance, you got a door and you need a key to unlock the door. Then you check if the player has the key, and if the answer is 1, then he has the key and he's allowed to open the door. If he does not have the key, the answer is 0 and therefore he is not allowed to enter the door. Because it's just two values, it's very easy to represent it with a checkbox. If it is empty, it is 0. If it is checked, then it is 1. I want to cover some operators available for the Boolean. This operator equal sign will always output true if the input values are the same. For instance, if both are true, then the output will be true. But this is also the case if both input values are false. If these input values are different from each other, then the output will be false. It's exactly the opposite with this operator. As long as the input is different to each other, for instance a true and a false, the output will be true. But if they are the same, the output will be false. So talking about a little bit more common operators for the Booleans, first of all I want to cover the not operator. So this here is a table to explain a logical expression. We got two different input values that are available, 0 and 1, and we got the not operator. The not operator is represented by this symbol in the Boolean logic. So what does it do? Your input value is 0, so the output will be 1, and if your input is 1, the output will be 0. And as you can see, we got here some operators that start with an N. And they just mean it's not and not or. So they are exactly the difference to the operator on the left side. So next thing is the AND operator. You can have multiple inputs. Here we have just 2 inputs, but you can also have 5 inputs and so on, but the logic will be the same. So this is just an example. I use the upper input for representing the row and the lower input to represent the column. So how does it work? Only if both inputs are true, or all inputs. If you got more, then the output will be true. And if you, in every other case, it will be false. So 0 and 0 will be false. And 1 and 0 will also be false. And here 0 and 1 will also be false. So only if both inputs are true, the output will be true. So when can you use it? For instance, if you want to craft something, you need resources to craft them. In my example, you need 4 resources to craft another item. And now you can check if they are available, and if the answer to each of these checkboxes is true, then you can craft the item. The opposite of the AND operator would be the not AND operator. And as I said, it's exactly the opposite of what we got above. So every time your result would be here a 0, it will be a 1, and if it would be a 1, it would be a 0. So for example, the input would be 1 and 1. In an AND we would have 1 as an output, but it is a not AND, so we got a 0. And in all other cases where it would be a 0, it will be a 1. 0 and 0 would be 0, but it's not, so it's a 1. And the same goes for the other values. So the next type I want to talk about is the OR operator. Same thing again, I just used one of the inputs as the row and one of the inputs as the columns. It does not matter what value you are using. So when is it true? It is always true when one of the available inputs is true. In our case we just have 2 inputs, but it would be the same if you have 10 inputs. If one input is true, then it is true. So in our case, the only false answer would be 0 and 0. This would be 0. But if we got 1 and 0, it will be 1, because we have at least 1, 1. Same as here. And also with 1 and 1, we got at least 1, 1, and so it's true. So we got the 1. So when do you need this? For example, if you got a door you want to unlock and you got available a key, or you got also a key card, and you don't care what the player found, you just open the door. So that would be an example for that. And also we got here the not or operator, which again does the opposite. So if we got here a 0 as an output, we will got here a 1 as an output. So the only situation where it will be true is when none of the inputs will be true. So 0 and 0 will be 1, 1 and 0 will be 0, 1 and 1 will also be 0. So the last operator I want to cover is the XOR. It's exclusive OR. So what does exclusive OR mean? It means only if one of the inputs is true, then the output will be true. So in our example here, if 0 and 0 is the input, it will be 0. And if the input is 1 and 1, it will also be 0, because we just want one input to be true. So in that case, 1 and 0 will be 1, and 0 and 1 will also result in true. So now you got your calculations done, and you need to feed it to something like a branch. And now here you got two execution pins. You got the true to follow, or you got the false. And now we ask, what is the result of this logical expression? If the result is false, like here it is, then we will go along this tree. And if the answer is true, then we will go along this line here. So this is how Booleans are working. So let's go to the next topic. The next topic is integer. What is an integer? An integer is a whole number, something like 0, 1, 2, 3, and so on. And also the negative values like -1, -2, -3. So it's not infinite. You got the minimum value and you got the maximum value. I don't know them, but we will see them later. So here we will cover the operators that are available, and there's nothing really much to tell about the addition and the subtraction, and also about the multiplication. Maybe some people of you don't know this operator. It's the increment, and this operator is the decrement. So how does it work? The decrement or the increment will increase the value of a given variable by 1. It's just a shortcut for reading the value of the operator, putting it into an addition at 1, and storing it again. And it's the same with the decrement. It will also subtract 1. If you really want to know how it is realized in the Unreal, then just double click it and you can see it, because it's just a blueprint. So the division and the modulo, if you don't know it. The division is a little bit special in integers, because as I told you, an integer is a whole number, 0, 1, 2, and so on. And now you got the issue of 5 divided by 2 is not an integer, but we just can only represent an integer, so we will do this. It will be 2. So what happens with the rest? And that's where you need the modulo operator. The same operation with 5 modulo 2 will result in the rest. It will be 1. So next to operators we got here is minimum and maximum. What do? They just do compare input values. And if you got an input value of 5 and you got an input value of 10, the minimum operator will just call the lower value. In that case, the output will be 5. And it's the opposite with the maximum operator. If you got the input of 1, 1000 and you got the input of 100, it will take the maximum value as an output value. So as an example, if you got your player and you got an HP of 100 and the player gets into a fight and the HP is reduced to 20, you would think you can just use the increment to increase the health, and that's correct. But if you are calling this without anything else, it will be 100 at some point, and then it will be 101, 102, and so on. So that's why we need a clamp. If you got a clamp, you got here your input value, which would in our example be 20, and the minimum value would be 0 for the minimum HP the player can have, and the maximum value would be 100. It does not matter what you put into here as a value, the output will always between 100 and 0. So in this example, if we would put in something like 120, the output would be 100. So you clamp the output value. Here we got some logical expressions. You may recognize the red circle from the Booleans, and that's because the result is a Boolean. You are comparing two different integer values and an output is true or false. If you don't know this sign here, it is smaller than, and it works like this. You got two input values. For example, you got the input value 5 and you got the input value 2. The question which is asked here with this operator is 5 smaller than 2? And if the answer is true, then the output will be true. But obviously it is false, so the output will be false. So we got here a pretty similar operator, but with a big difference. Because for our upper example, if we got an input value of 5 and 5, the question is 5 smaller than 5? The answer is false. And that's a special case, and usually you want to cover also this value, and then you say something like 5 is smaller or equal to 5, and then the answer will be true. These two operators are exactly the opposite. It's just the new symbol, which is smaller than, greater than. So if 5 is greater than 2, the answer is true. These two operators you already know from the Booleans. It's just comparing two values, and for the upper one, if the input values are different from each other, the output will be true. And for the lower one, if the input values are the same, then the output will be true. So another handy operator is this here, which checks if a given integer is inside the range. So you don't need to use more of these operators, you can also just use this function. So if your input value is, for example, 20, and your minimum value is 0 and the maximum value is 100, then you would have the output true. So that's almost everything I want to say to integer. The only thing I want to cover is the range of the integer. I prepared here the maximum value for an integer, and the minimum value of an integer is this number here. As you can see, here on the end is now an 8, while on the positive value is a 7. So I explain how this works and why it is like that. For instance, if you got just 16 values you can represent, then you would have -8 as the minus value. And the positive value also has 8 values, but plus is always used as a positive number, so you can't just go up to 7. So let's go to the next data type, it's the byte. I want to show you here an example what an overflow is. It's the same with float and with integer, but because there is not a lot of things to add to a byte, I want to show it here. What's the difference between byte and integer? Both are whole numbers, something like 0, 1, 2, 3. In the case of Unreal, this here is the maximum value, and the minimum value is 0. You don't have negative numbers. So again, here we got 256 values we can represent, but we use one place for 0, so the maximum value is 255. So, but now the question is, we got here 255 as a value, and we got here the value of 5. So what would you assume the result will be? 255 plus 5 will be 260. But as you know, the byte can't represent 260, so what will happen is a so-called overflow. Let's take a look at this. As you can see, it is 4. So the overflow is nothing else than taking the first value, taking the second value, and making addition, for example. And in that case, we got here an overflow because this is the maximum. So you can think it is working something like this. 255 plus 1 is 0. And then we add the remaining 4. 0 plus 4 is 4. So therefore we got the value 4. So always be careful when you're working on the edge of an operator. So the next operator I want to talk about is the float. The float is pretty similar again to the integer and to the byte, but the difference is it can represent fractions, something like 0.01 or something like 1.01, or also something like 1.0. You also can represent something like 5 million. Or 500,000 or 5 million, does not really matter. So you can represent a lot of numbers, but there is a big downside, and I want to talk about that. And that's the case where you always need to be careful, and you need to look if really the result is what you are thinking of the result should be. For instance, we got here a loop. 1000 times we are running through the loop. The initial value is 100 millions, and we are adding 1 for 1000 times. So we would assume the result will be 100,000, 100 millions, 1000. So let's see how it works out. And I press H, and as you can see here, it did nothing. It didn't change the value. So why is this? It is because how the float is working. It can't represent all the numbers. It can only just represent a certain set of numbers. And in our example here, we have to add at least a number of 8. And if I do it here, for instance, I try to add 5, and we run it again, the example, but just with one loop. You will see it added 8, because that's the next value we can represent. So always be careful when you are using a float value. Double check it. It's nice to have an output, and check if it really is what you are thinking of. So another example why you have to be careful when you are using a float operation. I prepared here a variable which is initialized with 0, and we are just adding 0.01, and we do this for 20 times. And I will call this method 5 times, and we will always see an output. And here in addition, I'm checking if our value is 1. Because for instance, it's again the HP of a player. If the HP reached 100, or in that case 1, we want to stop increasing the HP. So this might be a good idea to do it. So let's take a look how this works. So I pressed J1, so this is the result, and as you can imagine, 20 times 0.01 equals to 0.2, so that's okay, and it's not 1, so it's false. So everything is fine by now, and we are going to call it the second time, 3 times, 4 times, 5 times. So, and as you can see, here is an issue. We don't got the values we would expect. Instead of 1, we got 0.999, and that's the big issue with float operators. It has nothing to do with the value 1. It can represent 1, but because of the calculations we did, we got into this issue. And as you can imagine, we ain't got here 1, so it won't be true. So what does happen when we run it again? It also is not true, because we never hit exactly 1, which we would need for that operator. So that's why I would recommend in many cases that you are using the greater or equal sign. Because if we run now the same thing without any other change in the code, you can see it's still false here, but if we hit it again, it will be true. So it will be false here, but we will never exceed 1, and that's exactly what we wanted. So also be very careful if you're using the logical expressions. You should always, not always, but it's really recommended to check greater than instead of equal sign, equal sign. So that's everything I wanted to tell you about the primitive data types inside of Unreal. In the next video we will talk about the reference data types inside of Unreal. See you!